I don't think people understand just how awesome space is. It's full of incredible things that make us question what we know and how much there is still to learn. We can see some of these amazing events with telescopes, like giant explosions and invisible forces. Imagine the most powerful explosions you've ever seen or heard of. Now multiply that by 1 billion, then 1 trillion, and you're getting close to the power of a gamma-ray burst. These bursts are like the universe's fireworks, except they signal the death of massive stars. Then there are gravitational waves, these ripples in the fabric of spacetime that travel at the speed of light. Imagine dropping a pebble into a pond, and the ripples spread out, distorting the surface. That's kind of what gravitational waves do, except they're rippling through the universe. And who could forget about supernovae? These are the massive explosions that happen when giant stars die. They're so bright that they can outshine entire galaxies for a short time. Imagine a single light bulb suddenly becoming brighter than the entire city you live in. That's a supernova! Gamma-ray bursts are the most powerful explosions in the universe. They happen when a star much bigger than our sun collapses in on itself and then explodes. This explosion sends out a huge burst of gamma rays, which are a type of light that is even more energetic than X-rays. These bursts are so bright that we can see them from billions of light years away. In fact, they are the most distant objects that we can see in the universe. They only last for a few seconds, but in that time, they release more energy than our sun will in its entire lifetime. Scientists think that gamma-ray bursts might be caused by the birth of black holes. When a star collapses, it can form a black hole, which is an object so dense that nothing, not even light, can escape its gravity. Albert Einstein predicted gravitational waves over 100 years ago, but we only recently detected them for the first time in 2015. This discovery was a huge deal for scientists because it confirmed one of Einstein's most important theories, general relativity. So what are gravitational waves exactly? Imagine space and time as a giant trampoline. When massive objects like stars or black holes move around, they create ripples in this trampoline, which we call gravitational waves. These ripples are incredibly faint and hard to detect, but they carry information about the objects that created them. By studying gravitational waves, we can learn about some of the most extreme events in the universe, like the collisions of black holes. Section 4. Supernovae, the spectacular death of stars. Stars are born, they live for millions or billions of years, and then they die. But some stars go out with a bang, literally. These are called supernovae, and they're some of the most spectacular events in the universe. When a star much bigger than our sun runs out of fuel, its core collapses, causing a huge explosion that blasts the star's outer layers into space. This explosion is so bright that it can outshine an entire galaxy for a short time. Supernovae are important because they create and spread many of the elements that make up our bodies and our planet. For example, the iron in your blood and the calcium in your bones were created in the heart of a dying star. Section 5. Black hole singularities and the Big Bang mysteries of the cosmos. Black holes are some of the most mysterious objects in the universe. They form when massive stars collapse at the end of their lives, squeezing all their matter into an incredibly small space. This creates a region of space-time where gravity is so strong that nothing, not even light, can escape. At the center of a black hole is something called a singularity, which is a point of infinite density where the laws of physics as we know them break down. We don't really understand what happens at a singularity, but it's a fascinating area of research for physicists. And then there's the Big Bang, the event that scientists believe started our universe about 13.8 billion years ago. It's hard to wrap our heads around, but imagine all the matter and energy in the universe compressed into a single point, smaller than an atom. Suddenly, this point expanded rapidly, creating space and time and everything we see around us today. We've learned a lot about the Big Bang by studying the cosmic microwave background radiation, which is a faint afterglow of the Big Bang that still permeates the universe. But there are still many mysteries about the Big Bang and the early universe that we don't fully understand. If you enjoyed exploring these cosmic wonders with us, make sure to subscribe and hit the like button. Don't forget to click the notification bell so you never miss an update.